In this video, we're going to look at tree and Venn diagrams to help us calculate probabilities, and we're going to use them also to identify the sample space of a probability event. We talked about in our first video in this chapter what a tree diagram looked like. So now we're actually going to build a tree diagram, and what it does for us, it's a type of a graph that will show us the outcomes of an experiment, and each one of the branches are labeled with either the frequencies or the probabilities. And the tree diagrams can make some probabilities easier to visualize and solve. Usually we multiply down the branches. So we're going to use it to look at, you toss an unfair coin followed by drawing one bead from a cup containing 3 red, 4 yellow, and 5 blues. For the coin, the probability of a head is 2 out of 3. It is just 2 out of 3 as a fraction. So, and the probability of a tail is 1 out of 3. So that's how come we know it's an unfair die, because it should have been 1 out of 2. So in other words, the sample space should have been 2, head or tail. In this case, if you were to toss this coin, that 2 out of 3 times you get a head, and only 1 out of 3 times, 2 out of 3 times you're going to get a head, and 1 out of 3 times you're going to get a tail. So now we're going to draw a tree diagram for this. So what I'm going to do is I'm going to start out with labeling the heads and tails. So I'm going to make this the heads and this one the tails. Along the branch of my tree, I'm going to put in the probability as a decimal or a fraction. So 2/3 is the probability of getting a heads, and 1/3 is a tail. Now off of the heads, because we're going to first toss the coin, and then we're going to pull from a cup with the beads. And so we have red. So this is my red, and this is my red. And we also have the yellow. So here's the yellow, and here's the yellow. And then the last one is blue. So here's my blue, and here's my blue. Now we have a total of 12 coins. There are 3 out of 12 are red. So I'm going to put those down that probability branch. Of the yellow, there are 4 out of 12, 4 out of 12, and 4 out of 12. And then with their blue, there are 5. So we have 5 out of 12 and then 5 out of 12. Now I've got everything that I need to be able to answer the questions here. Find the probability that you have a head intersected with red. So head and red, or head intersect red. That's just going right down the branch. So I'm going to go down this head tail first, and then I'm going to go down this red. So I have 2/3 multiplied by 3/12. So the probability of a head is 2/3. The probability of a red is 3 out of 12. And so my answer would be, canceling my fractions, the 3's will cancel, the 2 will go into 2 ones, 2 will go into 12 6 times, is 1 out of 6. Now what's the probability of blue? Well, there are 2 ways to get blue. I can get a head then blue, or I can get a tail then blue. So this will be the probability of blue would be the probability of a head then blue plus the probability of a tail then blue. And as before, I'm just going to do 2/3 and 5/12 multiplied together for the probability of head and blue, and then 1/3 and 5/12 to get the probability of tail and blue. So this will be 2/3 multiplied by 5/12 plus 1/3 multiplied by 5/12. And I don't think I'm going to cancel anything because I want to have the same common denominator. So I'm going to multiply across, and I'm going to get 10 over 36 plus 5 over 36. So I get 15 out of 36. And I wrote 13. 15 out of 36. And this does reduce by a factor of 3 if I'm inclined. So 3 will go into 15 5 times. 3 will go into 36 12 times. And so I have 5/12 if I had to do the reduction. Now I'm going to look at the probability of a tail intersected, so or, not intersected, but or. union with, tail or a yellow. And so this is going to be, as we've talked about before from the very first video, we have the probability of a tail plus the probability of a tail intersected the yellow. We have a probability of a head intersected with the and, so it's an and, the yellow. And then I should probably pull off any overlap, and the overlap would be the probability of the tail intersected with the yellow. And so I'm going to probability of a tail is 1/3. The probability of, well, this and this will cancel themselves out. So I'm going to go ahead and not worry about those because they will cancel themselves out. And so I just have the probability of a head and yellow. The probability of a head was 2/3 and the probability of a yellow was 4/12. And I might do a reduction here. So let me see, I'm going to have, this will go in here once and here will go 3 times. And so I'm going to get 1/3 plus 2/9. I have to have the same common denominator, so I need to multiply this first one by 3, numerator and denominator, so I can actually add this stuff up. And so I'm going to end up with 3/9 plus 2/9, which gives me a total of 5/9. And that's it. Now let's look at a Venn diagram. Why would I use it and when would I use it? So a Venn diagram I would use if I've got, say I'm looking at a survey and some of the survey has the possibility to overlap. So I might do a Venn diagram to show when I'm counting the overlap of the survey outcome. We also will use this when we want to know what the cardinality is, in other words, the count of what I've got in each one of the groups, so the outcomes. And so cardinality just means I'm counting what's in the set. And it's denoted with an N outside, so the cardinality of A, in other words, how many pieces are in this event A. It's not the probability, it's just counting, right? So that's what that means. And then the complement, when we are looking at Venn diagrams, and will not have a prime, it'll have this, this superscript C, showing that it's a complement. And that means that we want all the elements that are not in the set A. So here's some examples of what you would see with a Venn diagram. And I'll actually do a true example. So here's A and here is B, and then we have this overlap here. So if I want the union of A and B, then it can either be in A, it could be in B, and then, you know, there's this overlap that is in both of them. So it basically would be, if I wanted A union B, I would be looking at this A, I would be looking at this B, and then I'd be looking at this overlap. And so I would add up those numbers that are already in there. Those numbers are already in there, so I would just be listing those numbers that are in there, or maybe I would be adding up those numbers if I wanted cardinality. So I want the intersection, and then with a Venn diagram, it's really nice because it just shows the intersection is where those two circles overlap. And in this case, I am looking at, I have this set H, I have the set F, and then I'd want everything not in the intersection. That's what this cardinality is. So not in the intersection, not in the and statement. So anything to begin with, so anything outside of that would be all of this, right? So that's what that piece would be. And then I want to intersect it, or in other words, where do I have overlap with just the W? And so that would be just that here. And you can see that in the red highlight, that it's just that part right there. And all of that is just showing me what the Venn diagram is. It's not telling me cardinality. It's not telling me probabilities. It's just telling me this is what I have. Okay, so now I have a survey of 200 people are asked, what beverage do you drink in the morning? The options are tea only, coffee only, soda only, both coffee and tea, but not soda, both coffee and soda, but not tea, both tea, soda, but not coffee, all three, or none of the three. Okay, so here's a place in which Venn diagram is pretty much like, this is what I want to do. Because I'm going to go ahead and I like to draw a box. Now, I just want to let you know that on the homework, you may not see boxes. So pay attention to if you have a box or not. And also pay attention to see if you have any numbers on this space that is not included in the circles I'm going to be drawing. So I'm going to first do my circle for coffee, and then I'm going to do a circle for tea. And since I know I have overlap, and I know I have overlap because it says tea only, coffee only, both coffee and tea. So this region right there is the both coffee and tea. So I'm going to make sure I have that in there. So let me redraw my circles. Oh, that's terrible. Let me put my circle back and then this circle back. And then I have soda as well. So I'm going to go ahead and then this is where my soda is going to go. Now I'm going to pay attention. So a total of 60 people said coffee. Now that means this entire circle has a total of 60 people in it that said coffee. I have 10 people that reported tea only. Well, that one's easy. I can put that right here in this space. That represents tea only. 40 people reported coffee only. Well, that's nice because now I know that the part that goes here out of that 60 is just 40. And 15 reported both tea and coffee, but not soda. So this is tea and coffee. And then this includes the soda, so the tea and coffee only, not soda, was going to go here. Now, let's keep reading, and we say, okay, 5 people reported all 3. 5 people reported all 3. Now, remember, it said that suppose 60 people said coffee, so I have 40 plus 15 plus 5. Oh, that's 60. That means that I don't have any people that said coffee and soda in the morning. There's no people that said coffee and soda, but not tea. So that represents the 0. Okay, so then we have 30 reported soda. So the whole thing should be 30. 7 reported both tea and soda. So I know that this one is 7. Now, if I have 30 that reported soda and I've already used up 5 plus 7, which is 12, that means I have 18 here. I surveyed a total of 200 people. I've filled in all of my pieces, my Venn diagram. That means I'm going to have some leftover that chose none of the above, right? So maybe on my survey I have none of the above. So what I would do is I would take the 200, I would subtract off the 40 in this region. I would subtract off an additional 15, which is in this region. I would subtract off an additional 5, that's from this region. I would then subtract off 10, that's from this region, and another 7 and 18. So that's that region and that region. And you're like, why didn't I just take off 40 and then take off the 30? Because I have overlaps. Because I have overlaps, I wouldn't just take the 200 and subtract off the 40 and then the other 30 and then this one, because I have overlaps. And so I'm just going to subtract off what I see in there, and what I end up with is 95. So 95 people said none of the above, or they left it blank, or whatever they did. So if I want to know the probability of choosing a person who drinks tea in the morning, I would look to see all of the region of tea. Okay, so I would look for the region of tea, and the probability of tea would be the number I see in there, which is 5 plus 15 is 20 plus 10 more, so I have 37 out of a total of 200. If I wanted the cardinality of tea, this is just 37. So then what is the probability of choosing a person who does not drink the given choices? Well, we know that's 95 people. So the probability, and I'm going to use n for none of the above, and so this would be 95 out of 200. The cardinality of n is just the count, and that's 95. And then what is the probability of choosing all 3 who drink? And that's just this middle piece right here. So this is this region right there that I just did in blue. That's all 3 drinks. And so the probability, I'm going to use A for all. and the probability of all is 5 out of 200. The cardinality of A would just be 5. So the cardinality just means count what I'm looking for, and then what the probability is. Now, another way I can write the probability of getting A is the probability of choosing soda intersected with choosing coffee intersected with choosing tea, and that is also 5 out of 200. And that's it for this video. Nice short one.